Hello students, I am Dr. Neera Sharma. Today I bring you a learning episode in BSc Forensic Science on behalf of the content writers Dr. Vimal Rar and myself on an important unit which is Analytical Chemistry, in which we will discuss in brief about the analytical techniques and its history. We will also discuss about various types of separation techniques and its application in forensic science. We will also study about the errors, standards, signals and noise. Let us start our module with a look at what we are going to learn today. Introduction and history of analytical chemistry, classification of separation techniques, classical methods including chemical test and flame test, electroanalytical techniques including potentiometry, voltammetry, coulometry, conductometry, instrumentation techniques comprises of chromatography, spectroscopy, distillation, solid phase extraction, solid phase microextraction, errors, standards, signals and noise, forensic application of analytical techniques, and finally we will conclude. Analytical chemistry has the widest range of application in the field of science. It uses various techniques and instrumentation for separating, identifying and quantifying the matter. The function of separation is isolation of the analyzed sample. Function of qualitative analysis is to identify the annihilate, and quantitative analysis is used to determine the amount or the concentration of annihilate. Generally, analytical chemistry is classified into three categories: classical methods, analytical techniques and instrumentation. Analytical chemistry can also be classified on the basis of qualitative and quantitative methods. Qualitative methods includes separation using distillation, extraction and precipitation. The identification is done on the basis of order, boiling point, color, melting point and reactivity. Quantitative method depends on changes in volume or mass to quantify the concentration of annihilate. Quantitative methods includes techniques like chromatography, electrophoresis, etc. Sometimes same instrument can also do separation, identification and quantification of the annihilate sample. The aim of analytical chemistry is to improve the experimental design of the instruments and methods and developing new tools for analysis. Analytical chemistry is used in medicinal science, forensic science and engineering. The importance of analytical chemistry can be seen from early time of chemistry. It was used in providing technique for determination of presence of elements and chemicals in quotients. During this time, analytical chemistry significantly contributed in growth of systematic analysis of elements by Justus von Liebig. It also contributed in organic analysis for particular reactions of functional groups. Flame emissive spectrometry was the very first instrumentational analysis developed by Gustav Kirchhoff and Robert Bunsen, and in 1860 they also discovered the element cesium and rubidium. After 1900s, the major growth was seen in analytical chemistry. In this period, there was exponential increase in the use of instrumental analysis and became one of the most dominant fields. In 20th century, spectrometry and spectroscopic techniques were developed. The analytical chemistry progressively changes the techniques and instruments into instruments of high performance. In 1970s, hybrid techniques came into the picture. Many methods and techniques were started to be used together. From 1970s, many developments took place in the field of analytical chemistry, like earlier it focused on smaller molecules, but then it was progressively used in biochemistry. Similarly, laser came into picture and its use was increasing day by day for initiating and influencing many reactions. From late 20th century, the range of applications of analytical chemistry is increasing day by day in the field of forensic science to environmental science and industrial science also. The modern analytical techniques are dominated by high-end instruments, but the main roots and principle of analytical chemistry lies in traditional methods like chemical test and flame test. These tests are used for qualitative analysis of annihilate sample. Basically, the aim of qualitative analysis is to determine the absence or presence of annihilate. It is not focused on determining the concentration of the annihilate. Classical methods are of two types, classical test and flame test. Chemical test. It is a process aimed to prove the presence of a chemical annihilate with the help of a particular reagent or chemicals. Flame test. It is a process aimed to prove the existence of chemical annihilate or metal ions. This technique is based on the characteristic of elements emission spectrum. The procedure of the flame test is very simple. It involves presenting the annihilate into a non-luminous and hot flame, and then the color of the flame is observed. The basic principle is behind flame test is that atoms present in the annihilate may evaporate in the flame and emits light when they are in the flame. All the electroanalytical techniques are based on the relationship between chemistry and electricity. For instance, like measurements of electrical quantities like charge, current or potential and their association with parameters like concentration. There are wide range of application of electroanalytical techniques in the field of industries, biomedical sciences and environmental sciences. Majority of these techniques deals with studies related to chemical changes initiated by channel of electric current and producing electrical energy from chemical reactions. Electroanalytical techniques are also known as electrochemistry because this term is invented from study of electron movement in oxidation reduction reactions. Electroanalytical techniques are classified into four categories: potentiometry, voltammetry, coulometry and conductometry. Potentiometry. This technique is used to quantify the potential of a solution using two electrodes. Then this potential is associated to the concentration of annihilates. A cell is used to conduct the experiment. This cell comprises of two electrodes in which one of them is indicator electrode and other one is reference electrode. The potential of indicator electrode is based on concentration of the ions of annihilates, whereas the reference electrode is independent of ion concentration of the annihilate in the solution. Voltammetry. In this technique, varying or constant amount of potential is applied to surface of an electrode and it quantifies the current produced with the help of three electrode system. The voltammetric experiments are carried out in an electrochemical cell. An electrochemical cell is composed of three types of electrodes: working electrode, counter or auxiliary electrode and reference electrode. At working electrode, all the reactions are transferred takes place and it is an electron conductor. In every voltammetric experiments, it is compulsory that one of the electrode is kept at constant potential. the reference electrode is designed in such a way that it has constant potential. For harmonizing the total charge in the electrode cell, counter reaction takes place at auxiliary electrode. Electroactive species are present in the electrochemical cell. Their concentration changes on the surface of the electrode by electrochemically oxidizing and reducing these species. Now we will see coulometry. This technique is used to measure the quantity of matter that is converted during electrolysis reaction. This step is completed by calculating the quantity of electricity produced or consumed. In this technique, the annihilate is fully reduced or oxidized at the working electrode, or in other words, the annihilate completely reacts with the reagent produced at the working electrode. A coulometric cell consists of working electrode and auxiliary electrode. Conductometry. Electrolytes includes colloidal systems, solids, aqueous and non-aqueous are analyzed. In conductometry, the progress of a chemical reaction is monitored by measuring the electrolytic conductance of a solution, which arises when ions of the electrolyte transport charge through the bulk of the solution. In conductometric measurements, the electrodes are placed in intimate contact with the solution and an alternate potential is applied. Now let us see the instrumentation techniques. Instrumentation techniques are used for identification and separation purposes. They are also used for qualitative and quantitative analysis. Some of the instrumentation techniques are explained here. Chromatography. It is a set of all techniques used to separate components from mixture. Separation is done with passing the mixture through two phases, and one is mobile phase and other is stationary phase. Techniques involved are thin layer chromatography TLC, high performance thin layer chromatography HPTLC, gas chromatography GC, high performance liquid chromatography HPLC. Spectroscopy. It is basically a study of interaction of electromagnetic radiation with matter. It is used to determine the functional group and structure of organic matter. Techniques involved are UV visible spectrophotometer, FTIR Fourier transform infrared spectroscopy, Raman spectroscopy, atomic absorption spectrophotometer AAS, ICP-MS inductively coupled plasma mass spectroscopy and MS mass spectroscopy. Spectroscopy is of two types, atomic and molecular spectroscopy. The only difference between these two is that in atomic spectroscopy, the atoms interact with electromagnetic radiation, whereas in molecular spectroscopy, the molecules interact with electromagnetic radiation. Distillation. It is a process of many steps, yet it is simple to conduct. It is a separation process. Distillation comprises of heating the liquid sample to its boiling point. The vapors will form. Then these vapors are transferred into the different parts of the apparatus where condensing of vapors takes place, and then it is collected into a container. Distillation is found to be very efficient for those liquid compounds having different boiling points. Distillation is mostly used in industrial applications like crude oil separation. From chemistry point of view, distillation is used to purify the liquid compounds. Solid phase extraction. It is a technique of sample preparation. The work of solid phase extraction is to purify the annihilate and concentrate it by adsorbing it into the solid phase, which is followed by elution of annihilate sample with a solvent. SPE separates dissolved constituents present in a liquid mixture. The separation depends on the chemical and physical property of constituents present in the mixture. SPE is used for isolation of body fluids such as blood, urine, animal tissue, etc. It is divided into three categories: normal phase SPE. Solid phase extraction is done in 5 basic steps. Equilibration of the cartridge is done with a non-polar solvent. Sometimes slightly polar solvent is also used. This equilibration wets the surface of the cartridge and enters the bonded phase. Washing of the column is done using water or buffer. This buffer is made of same composition as that of sample. This washing is done to wet the silica surface. Sample is added to the cartridge. Non-polar solvent and impurities will pass through the cartridge and the remaining polar annihilates will retain on the polar sorbent. Washing of cartridge is done with non-polar solvent so as to remove leftover impurities after loading of sample. Then at last, using a polar solvent or a buffer of optimum pH, the annihilate is eluted. Reversed phase SPE. Separation of annihilates according to their polarity is the basic principle of reverse phase SPE. The cartridge of reverse SPE is derivated using hydrocarbon chains, which produces hydrophobic effect and withholds the compounds of mid to low polarity. Elution of annihilate is done using a non-polar solvent. This washing of cartridge ruptures the bonding between the annihilate and stationary phase. Silicon with carbon chain is mainly used as stationary phase. Adsorption of non-polar and slightly polar compounds will take place at the surface. Ion exchange SPE. Electrostatic interaction between the annihilate and positively charged particles present on the stationary phase is the basic principle of ion exchange SPE. A proper pH should be maintained for ion exchange to occur. Stationary phase and sample both should be charged at this pH. Solid phase microextraction. To get a productive separation, large amount of annihilate was required in case of solid phase extraction. Since in forensic science, very small quantity of sample is available at crime scenes. So, in last few years, development has taken place and solid phase extraction has been modified into solid phase microextraction. This modification proved to be very useful as it can be used for very less quantity of samples. SPME reduces the time necessary for sample preparation, decreases purchase and disposal cost of solvents and can improve the detection limits. Charcoal is used as an adsorbent in solid phase microextraction, which is coated on a small wire which is attached to a holder. This holder is used to extend or withdraw the wire. For adsorption to take place, this wire is outstretched into a vapor or liquid. After this wire is introduced into a gas chromatograph, during gas chromatography, the adsorbed materials are separated and then analysis is done. Massive reduction or elimination of solvent consumption and the subsequent issues of used solvent disposal as part of sample preparation can be resolved using SPME. Both GC and liquid chromatography separations can be achieved using SPME. It is a simple, effective adsorption-desorption technique. The thrust upon which SPME relies is the extraction of solutes from a sample into SPME absorptive layer. The adsorbed solutes are transferred with the SPME layer into an inlet system that desorbs the solutes into a gas or liquid mobile phase after achieving equilibrium. Successful extraction can be done by choosing conditions which are favorable for solutes. For example, in presence of bulk sample, the solute favors the SPME absorptive layer, and again conditions are changed to release the solute from absorptive layer for chromatographic analysis. When desorption is too slow to allow full use of column resolving power, secondary trapping and release of desorbed solutes after SPME becomes sometimes necessary. Such a process of trapping and release can be achieved using a discrete thermal trap or with column stationary phase, trapping by injection onto a cold column and subsequently temperature programming for solute elutions. There are various parameters which affect the process and result of techniques and instrumental process of analytical chemistry. Some of them are discussed in this paper. Errors are divided into two categories: random error and systematic error. Random error influences the precision of measurement. This error results in scattered data which is less or more symmetrically near a mean value. Systematic error influences the precision of results. This error results in set of the data to vary from standard accepted value. Standard error arises from imperfections present in the components of instruments, errors created by carelessness or not giving proper attention to the instrumentation. Standards. These are the materials which is used in analytical chemistry to standardize or calibrate the analytical technique. Standards are the materials whose concentration is already known and they are used in quantitative analysis. Standards are also called as reference materials because it is used as reference for determining the concentration of unknown analyte. Standards are of two types, primary and secondary standard. Primary standard is pure and stable compounds and it also has high molecular weight. The main function of secondary standard is to calibrate the primary standard. Signal and noise. A signal may be defined as the output of a transducer that is responding to the chemical system of interest. The signal may be separated into two parts, one caused by the annihilate and other caused by the components of the sample matrix and the instrumentation used in the measurement. This later part of the signal is known as noise. As concentrations of the annihilate decrease to trace levels or as signal sources become weak, the problem of distinguishing signals from noise becomes increasingly difficult, resulting in decreased accuracy and precision in measurements. The ability of an instrument system to discriminate between signals and noise is usually expressed as a signal to noise ratio, where S is equals to average signal amplitude and N is average noise amplitude. Noise enters a measurement system from environmental sources external to the measurement system, or it appears as a result of fundamental intrinsic property of the system. There are various devices which can reduce the noise like filtering, demodulation, modulation, integration, etc. Analysis of narcotics and drug testing, determination of alcohol in blood, ink analysis, drug overdose study, detection of paints and soils, detection of organic compounds and its functional groups, in qualitative and quantitative chemical analysis, detection of polymers, fibers and plastics, analyzing toxicity in body fluids, in arson examination, in examination of explosives. It is used for acidic distillation of volatile liquids like ethanol, methanol, phenol halogenated hydrocarbons and cyanides. It is used for basic distillation of basic drugs like amphetamine, methadone, aniline, pyridine, nicotine, etc. It is also used in fractionation of petroleum hydrocarbons. It is used in screening of body fluids like blood, urine, etc. for presence of any drug and poison or its metabolite. It is used in determining presence of herbicides in water. It is used in trace metal analysis. Analytical chemistry has widest range of application in the field of science. The function of separation is isolation of the analyzed sample. Function of qualitative analysis is to identify the annihilate, and quantitative analysis is used to determine the amount or the concentration of annihilate. Analytical chemistry is classified into three categories: classical methods, electroanalytical techniques, and instrumentation. Quantitative method depend on changes in volume or mass to quantify the concentration of annihilate. The aim of analytical chemistry is to improve the experimental design of the instrument and methods and developing new tools for analysis. All the electroanalytical techniques are based on the relationship between the chemistry and electricity. For instance, like measurement of electrical quantities like charge, current or potential, and their association with parameters like concentration. Spectroscopy is basically a study of interaction of electromagnetic radiation with matter. It is used to determine the functional group and structure of organic matter. There are various parameters which affect the process and result of the techniques and instrumental process of analytical chemistry. Some of them are error, standard, signal and noise. Now this is time for your self-study. If you want to learn more for enhancing your knowledge, you may log on to our website www.cec.nic.in for assignments, MCQs, quizzes and LORs and other materials. Till then, keep studying. Goodbye.